Let's use rational exponents to simplify and then write our final answer as a single radical. Assume that all variables represent positive real numbers. So that means we don't have to worry about absolute value bars. Okay. For a, the 10th root of y to the 5th. So the first thing I want to do is change this to rational exponent. So remember, the nth root of a to the m is a to the m over n. So the base and the numerator are the radicand, and the index is going to be the denominator here. Then I want to simplify because I can divide 5 from each of those, and that will leave 1/2. But now I need to bring this back to a single radical. So a radical where the index is the denominator, so understood 2, and the radicand is the base with the numerator. So just square root of y. In example B, the 4th root of 9. So first thing I want to do is change this to an exponent. So 9 to the 1/4. And 1/4 is simplified already, so there's something else going on here. Can I change the base? Can I make, instead of a base 9, a smaller base? Is there something squared or cubed or anything that equals 9? Well, 9's a perfect square, right? 9 is 3 squared. So instead of 9, I'll put 3 squared to the 1/4 power. And then I have to multiply powers. 2 times 1/4. So multiply numerators, multiply denominators, and we get 2/4, which can be simplified to 1/2 if we divide 2 from the numerator and denominator. And now I want to get this into a single radical, so the index is the 2, that's understood, and the radicand is the base with the numerator. So 3 to the 1 is 3. Square root of 3, that's my final answer. For C, I've got a big base here, so a to the 6th, n to the 3rd is the base to the 1 over the index. And then really what I have is a product to a power, so let me go ahead and do that. A to the 6th to the 1/9 times n to the 3rd to the 1/9. And then I have the power rule here, so multiply powers. 6 times 1/9 is 6/9. And 3 times 1/9 is 3/9. Okay. Then I can simplify those exponents. So 6/9, I can divide 3 from each of those, so that'll be 2/3. And for 3/9, I could divide 3 from both of those. That'll simplify to 1/3. And now I need to go back to a single radical. So I need to go back to where these had the same exponent. Okay, so notice they do have that same denominator of 3, so let's use that. And then the numerator stays with them, so a squared and n to the 1. Now I can force that back into a radical with the index, which is 3, and the radicand is a squared n. So that's our simplified single radical. For D, I want to change these to rational exponents, so the square root will be 2 in the denominator of the exponent, and a cubed root will be 3 in the denominator of the exponent. So this is going to be a product rule here. Multiply the same base, keep that base, and add the exponents together. Okay, so 1/2 plus 1/3, I need to get these to have the same denominator. And so the least common denominator is 6. To get that, I have to multiply 1/2 by 3 over 3 and 1/3 by 2 over 2. Okay, so now I've got y to the 3/6 plus 2/6, which is 5/6 altogether, if I add the numerators. And that's simplified. 5 divided by 6 can't be simplified any further. So now I can put that back into radical notation where the index is the denominator, and the radicand is y to the 5th. Example E, I need to change these to rational exponents, so x to the 1 over the index of 3 in the numerator, denominator x to the 1 over the index of 4. And so I have a quotient here. I can keep that base and subtract the exponents, 1/3 minus 1/4. Well, I need to get equivalent fractions with the same denominator for each of those. So 3 times 4 gets us the least common denominator of 12, which means I need to multiply 1/3 by 4 over 4 and 1/4 by 3 over 3 to get my equivalent fractions here. So 1/3 is 4/12 and 1/4 is 3/12. Okay. So then I could subtract the numerators. 4 minus 3 is 1 over the denominator. And 1/12 is as simple as that exponent gets. So now let me put that into a radical form where the index is the denominator and the radicand is the base. So 12th root of x. Then for f, I need to change these to rational exponents. So 5 to the 1 over the index of 2 times 2 to the 1 over the index of 3. Okay. Well, those are simplified, right? So what do I need to do to these? I need them to have the same index because I cannot put these numbers under the same radical unless they have the same index. So that's my goal here. I need to have the same index, which is the denominators, right? So I need these denominators to be the same. So I need equivalent fractions for 1/2 and 1/3 such that they have the least common denominator 2 times 3 of 6. Okay. So I need to multiply by 3 for the 1/2 and 2 for the 1/3. So then that's going to change to 5 to the 3/6 times 2 to the 2/6. Okay. Now that they have the same denominator, let me write that as a product to that power 1/6 because that's what I want, right? So then everything else stays the same. 5 to the 3rd times 2 to the 2nd. And I can actually multiply those together. So 5 to the 3rd is 125 and 2 squared is 4. And 125 times 4 is 500 to the 1/6. So now I just need that single radical. So the denominator is the index and the radicand is 500.